So I kind of geared at least the beginning of this to the people who were here from the security class 2 weeks ago. But since none of them are here, it doesn't really matter. But I think most of you were here and you worked through with them on user access control and using change mod and new mask settings. I think Chase and Nathan, were you here for that? When we did
No,
2 weeks ago?
No.
Thursday. I know.
That's the one we missed.
Yeah, that's one we missed.
Missed it.
But if you want, I can give you the details, but we went through a hands-on exercise where people got into pairs and logged in as 2 different users, and they would create a file, change permissions, the other user would try and access it, change permissions again, see if they could start figuring out how user permissions would change things. And then we did the same with directories and seeing how doing changes on the directory would affect the creation or deletion of files inside that directory. Kit, you were part of this, and I think you did it, didn't you? Mm-hmm. What did you guys think of it? Did you find stuff out?
It was informative, especially to people who weren't probably familiar with it at all.
Yeah.
I even learned a couple things. So.
Cool. How about you?
I had fun with it.
You had fun with it? You were having a whale of a time, I remember. So let's look at why all of that works. So initially, as most of us know, Linux uses what we call an MAE tree structure. So we've got root at the top, and then everything else hangs off of it. And even our other disk partitions or other network partitions all hang off of this. And most of you have already got this pretty much down, but just so we've got it. It's known as the File System Hierarchy Standard. And ultimately, as we'll find out, as most of you have seen already, this boils down to files. All of these directories actually are files themselves. They're just something slightly different. So, let's see what we get. All right. Oh. This thing's a little bit slow. There we go. No. I'm just going to do it once and then stop. There we go. Okay. Hey. Are you picking up the green on black okay?
Yep, that's good.
Right.
Yeah, if it's big enough, it doesn't matter.
Yeah. It's big enough. So what does ls-rla do? Anyone want to tell us what ls stands for?
List.
List the directory. What are the options?
You're seeing all.
Long list, all, I don't know if you are.
Yeah, I was gonna look up
R is recursive.
R is recursive. So long listing, so we get our permissions. All, so we get hidden files. What in Linux denotes a hidden file?
A dot.
A dot within the file. And then R is recursive, so not only are we seeing the current directory, but we're seeing directory 1 and directory 2 all in the same list. Alright, who wants to take us through what some of these are? We did do this a couple weeks ago, but what are these two?
User and group.
User and group of, and my last name, user and group of what? The file ownership. So this is who the file belongs to and the group that the file belongs to. And then here, what have we got around here?
Permissions.
Permissions. How's it broken down?
Well, the first part is user and group.
Other. What's another word for other? World. I hate the word, but quite often people call it world, which is really infuriating. I noticed a number of people got really stuck on the exercises 2 weeks ago, because we used change mod on both octal numbers as a syntax and symbolic syntax. And symbolic syntax is things like, what's that? One of the symbolic syntax that we did was change mode, and it was U minus W O equals W. So it was change mod U minus W and O equals W dot. And a lot of people got really confused because they thought the W meant world. What does the W mean? Right. What's U mean?
User.
User.
An O? Not owner.
It's other.
Other. And that's why I get really infuriated when people call it world, because it doesn't match syntax that you're typing. The syntax is other. And other is kind of now standard within Linux. I'm sure there's probably somewhere that calls it world in Unix history.
It's maybe.
I remember when I learned it, they called it world. It's still O.
Well, it's called world.
Yeah.
So yeah, it confused a lot of people because they kept thinking W meant world and didn't know what O was and got very confused. So what does this change mode do? Since most of you were not here, for those of you who were, what did you do when you did this?
Change file permission.
Well, actually, if we did it on the dot, what were you doing?
Oh, change directory.
Change the current directory. So we take away write from the user, and we make other what? Only write, equaling write. And I actually learned that because I don't use symbolic syntax. I use octal.
See, sometimes for me, I almost always use octal, but sometimes it's easier not to figure the numbers out.
Yeah.
It's easier just
Just
to
to
do
do
something
that.
like this.
And I know
It's really simple.
exactly. And I know that Dominic uses symbolic all the time. I don't know where Dominic disappeared
He
to.
stepped out for a minute. We'll be back.
But yeah. So we've got permissions. We've got our user root that owns the files. How about this one here?
Directory or file, right?
Yeah, file type. So standard file, directory. What other file types are there? I know that you and I went over this.
Sockets, right?
Sockets,
one.
yes. Two others? Two other file types that aren't usually used?
Device files.
Device files. So what kind of devices are there?
Like input devices like mouses and.
No, let's not worry about mice. How about keyboard? What might a keyboard you be used as a device?
Seems like it's external input device.
Yeah, what type of device? Is it? There's two. I'll tell you this. There's
yeah,
two
yeah.
different types of devices. Device types.
Input not.
No, it's character and block.
Right. Block.
So what would be a character device?
Keyboard.
Like a keyboard or a
Mouse.
serial connection,
TTY, yeah.
possibly a mouse, TTY. How about a block device? What would be a block device?
That would be hard drives.
Hard drives,
Disk drive.
old floppy drives, flash drives, tape drives. So yeah. And so they will be denoted here as C or B. And then there's also P, which is pipes. You can create pipes as well. So we've got all of that stuff. What's the time and the date?
Modified.
Modified. So that was the last time that file was modified. Over here, pretty self-explanatory, but what is it?
File name order.
File names. What's the dot? What's the double dot?
Dot is current directory.
Dot. Single dot is the current directory.
Double dot's the last directory.
Double dot is
Parent directory.
parent directory. Yeah.
Oh, parent.
So this double dot is this directory. And actually not lastly,
And the dots and inodes create the directory tree structure. Why it's organized like you had in the first chart you showed.
absolutely. You're going to see quite a lot of because you didn't come to the Linux Festival. You're going to see quite a lot of Keras schematics when we get into it. How about this? What does that total mean? Total in a number. I know that we talked about this when I gave this the last time. And remember what those are? Total 8.
Is that the number of inode links to it?
Not inode
Does-
links.
What does that have to do with, like, I noticed that when you have your file, you have directory, and you have all the groups, you have user group and other all have read, write, and execute
Yeah.
available.
This isn't related to permissions.
Oh, okay.
No. This is related to number of blocks used for the files that are inside it. And if I tell you that the system that this test example was done on had a block size, file block size of essentially 1 kilobyte, 1024 bytes. So that would be 1024 bytes times 8 is the size of what's listed in that directory. And if you put a H at the end of the ls, you would actually start getting it in human form. What about this? That's the size of the file itself. What does 4096 mean? Sorry?
That'd be 4 blocks.
It would be 4 blocks, you're right, but
But that's not what it means.
no, it's file size. What if you're not doing human readable, where it actually calculates and has a nice little encoded letter? What's it going to be defaulting as? Bytes. So this is 4 kilobytes. So you can now read it without needing to do the human read thing. All right, we are going to get on to this number, but I don't want to go into it yet. Those of you who know. So, file system types. How many can you recognize?
They're all Linux.
Half of them are Linux, half not.
Oh, down there, okay, yeah.
So we've got Extent 2FS, which I remember using about 10 years ago. I'm sure you did. Extent 3FS, which kind of stuck around for a couple of years and then disappeared because it got taken over by Extent 4FS. So the nice thing about, and this is the stuff that we really don't realize. 16, what would be TIB?
Terabyte file
It's
size.
not terabyte,
Oh, really?
terabytes.
Holy.
What's the difference between a terabyte and a kilobyte?
A lot.
No, actually, there isn't that much difference.
It's the
Sorry?
base.
It's the base. Terabyte is base what? 10. So when you're saying a 4 kilobyte file, you're saying it's 4,000 bytes. How about 4 kilobytes? What base is a kilobyte? What base is a base 2? So 2 to the power of, what would be 2 to the power, what would be a kilobyte? 2 to the power of what? Sorry?
10?
2 to the power of 10?
2 to the power 10.
2 to the power of 10? So that's when you start getting into the 96 and the 24 and all of that kind of stuff, is because it's not to the base, it's not using base 2 when we talk about terabytes and things like that. Is that making sense to everyone?
Yeah.
So that's a new term. And if you take, I think it's routing and switching 1, that will be a real problem for you, because there were half the class when we're doing calculations we're using base 10 and half the class are using base 2. And the class who was using base 2 were actually wrong because he hadn't specified that. So you've got to be really careful. You've got to be really careful there. Riser FS, anyone play with Riser FS? I did years ago. It's very similar to Extent 4, but it's really good for handling lots of really small files. What would be a good example of lots of really small files?
As a reminder.
Reminders? There you go. What would be another good application for some kind of file system that needs lots and lots and lots of little files?
Lots and lots of what?
Small files. We're looking
Small
at
files.
Riser FS. It's very similar to the other types of file systems, but it can handle very large amounts of small files. What's a good application for? Have you ever come across an application where you need lots and lots of?
It's probably security cameras if they're doing that in
Yeah,
pictures.
that's
Yeah.
what
I
you
can
would
think of like sensor data.
Sensor data.
If you're not-
How about emails, sir?
Yeah.
How many emails are that big?
Is that where Node-REDs are from? Was there like some mainstream email
Could be.
that used it?
It could be.
Email server would be great.
Yeah. And anyone come across ButterFS? BTRFS?
I've never played with that, but it will.
I agree with you saying that it will.
Yeah, that's what they're
It's the
saying.
it's the new sexy popular file
It's
system right now.
it's essentially, I kind of get the vibe that it's Linux's variant on ZFS.
Oh, really? That's what BTFS is?
BTR.
Yeah. It's, I think it's known as ButterFS.
Yeah.
as it's
Yeah, it's pronounced.
pronounced. It's a bit like the new gnome is not mate, it's mate, as in
What?
the drink.
What?
Yeah,
I didn't know
it
that.
should have the accent at the end of the on the e, and it
That's
doesn't.
crazy.
But they pronounce it mate, so it's the same thing. How about non-Linux? How many people still have to use FAT?
Flash drive.
Why do you have to use FAT still?
Because they put it on flash drives.
You can reformat a flash
You
drive.
could.
Yes.
Some devices still only take fat, especially older ones.
If I want to write a file from an Apple computer and then read it in a Windows or a Linux box, what file system can I use? Can I use HFS or HFS Plus, which is the Apple Mac file system? Strangely enough, I can if I want to read it in Linux. Ubuntu, certainly I've noticed, actually can read the HFS file system. Windows, no. But Windows writes NTFS. I'm sure everyone's come across the new technology file system, which they keep upgrading and upgrading and upgrading. I think it has German support now, finally. But if you ever try plugging an NTFS drive into a Mac, the Mac will read it, but it can't write to it. Even now, Linux has had NTFS read and write support for a good 5 years now. Mac still hasn't gone beyond read only. So the only thing that you can do to do interoperability between Mac, Linux, and Windows is FAT.
Oh, brother.
Yeah, the brother's right. And it's got some real limitations.
Yeah, file size.
File size is a big problem. Anyone know what the largest file size you can do on FAT32?
4 gig.
4 gig, yes. Yes, 4 gigabytes. How many people have video files that are bigger than 4 gig?
Meeting.
and yet flash drives, external hard drives are still formatted in FAT. What's another big limitation of FAT that if you try and back up, a good example is an ordinary user who's using Windows buys an external hard drive to back up their data, and they, rather than using Windows backup, they do a copy and paste, or they drag and drop. And suddenly it comes up with a whole bunch of errors, and half of their data doesn't transfer. Why not?
Permissions, right?
Not permissions. FAT and NTFS don't really do with permissions. It's not like actually that brings up a very good point. All the Extend series and the Riser FS and stuff handle Linux file permissions. NTFS and FAT do not. So if you want to mount them in Linux, you actually have to force permissions when you mount, or it does it as a default permissions. But going back to my original scenario, why would someone who has an NTFS formatted hard drive running Windows, buys an external hard drive, tries to copy all that data across, and gets a whole bunch of random errors?
because it's specific to the hard drive?
Not quite. It's a limitation of fact.
I remember running into it, but I can't remember what it was. It was so long.
Not only does FAT have a 4 terabyte maximum file size, but it also has a limit on the number of characters, not of a file, but of a path.
Oh,
And so if
tables.
you've got lots of nested directories and then files inside that, for example, what would be a good example of a whole bunch of nested directories in Windows and then a whole bunch of file names?
Anything in Windows?
Anything in Windows. Well, how's about the internet cache of Firefox? And you've got these big long names and it's all the way down the line. So nowadays, I don't know why, but because of the issue that it's still supported by, for example, Mac, all the manufacturers are still doing FAT. But if you don't know about file systems, you can get really, really, really gammed up when you try and utilize them. Because NTFS doesn't have that problem, so it has these big long file names, and then you try and save it onto FAT, and it glitches out. Little interesting things that if you bounced around with Windows for years, you'd probably find. ZFS, I know our FreeBSD boys can probably tell us the greatness of ZFS. You want to give us a rundown on the benefits of ZFS?
There's a good for Sun systems.
Any kind of limitation that the other file systems are going to run into, ZFS blows it out of the water. It was designed that way. It was designed so that realistically, by the time we hit those limitations, ZFS will be so old nobody uses it. That was the idea. Now, time will tell. But that was a big one for when they started making it. It also solves a lot of the problems with redundancy that RAID has, because sometimes RAID will lose information, especially over long periods of time. And it fixes all those problems, but still has all the functions of your RAID setups, as well as adding features that handle the logic that deals with drives that are of different sizes and things like that, whereas RAID can't handle. It has snapshots built in, which is nice. It has journaling. It has.
And there's also an error correction that's not. Didn't do something for error correction.
If you have ECC memory,
Well, it's not.
you kind of need error correction memory.
Yeah.
I was going to say, what's the limitation of ZFS?
Memory. It is extremely memory intensive.
If you have an older computer that you're trying to turn into a server, ZFS is probably not a file system.
That really only comes into play if you're trying to do a higher level redundancy, I guess.
Right.
And if you're doing a lot of I/O on it.
Or
Otherwise,
snap-
it'll just kind of sit there.
Or snapshotting.
Yeah.
There's a feature, I can't even remember what it's called. There's a feature where it will search through your data and it will look for copies of data. Like if different people have the same picture.
Yeah.
Deduplication. So deduplication is where it'll scan all of your data and it'll look for bits that are the same essentially. And then it will store it only once and make the other version of it just a link to the one stored one, which can save lots of space, but that is insanely memory intensive.
FreeNAS that uses ZFS as a standard, it says, do not turn on deduplication unless you absolutely know what you're doing, because it will really take your performance and plummet it down.
And aside from that, I also would make sure you never use any of the advanced features of ZFS on FreeNAS. Because FreeNAS adds their own layers of stuff on top of ZFS, and that can end up causing you lots of problems in the end. Especially if you've been running it for years, and then something breaks, and then you go to the ZFS guys for help. They're going to be like, nah, dude, we don't know. I mean, that's...
I don't know what they're doing over there.
So ZFS is essentially software RAID.
It's a
It's part of what it does.
High level
components
stuff.
It can do the RAID. RAID is part of it. You don't have to use
So
RAID.
if you're RAID, because I assume that's one of the big advantages to using ZFS.
Yes.
What is the performance hit CPU-wise on something like that, in your experience?
CPU's not much.
Yeah.
Memory is much.
Memory's the big one. CPU not.
Because I purposely have a hardware restart
No.
to save on.
If you're doing it on a 32-bit processor, you're going to have to tune some kernel stuff.
Yeah.
But if it's a 64-bit processor and you have plenty of memory, you're good to go.
Do you remember what the disk limitation sizes are?
It's insane.
It's insanely big.
I don't remember, but it's in the petabyte.
It's
Now, if
ridiculous.
you think extent for
Well, it's
the
called a
maximum
zettabyte
disk
file
size
system.
is
A zettabyte.
16 terabytes.
It's a zettabyte file
It's a
system.
zettabyte file system. It is absolutely crazy.
I'm just excited that we finally have a file system that's Y2K compliant.
It's what?
Yeah, otherwise we'll be looking for John Teeter in 2032, man.
I remember when Extent 4 FS came out, and I was thinking, well, no one really for a while is going to hit that mark. My server right now is sitting at 12 terabytes, and the moment it is partitioned, I'm using logical volume management to partition it out. But if I just made it a very large disk, I'd be starting to get close to this limit already. So it needs those things where zettabyte file system, you think, well, no one's ever going to hit the petabyte range, but
Give it.
we probably
5
will.
years.
Give it, well, maybe 10, but yeah. Anyone come across ISO 9660?
CD-ROMs for sure.
CD-ROMs, the old school CD-ROM sets.
I have some specs on ZFS here.
Oh, you do? Go for
Alright.
it. Go for it.
So here's some of the limits we hit. Max volume size, 256 zebibytes.
Oh, it's not independent on it.
Max file size, 16 XB bytes. Max number of files is 2 to the 48. They don't even name it. They just Max file length is 255 characters. And that's about it.
That's pretty insightful.
That's pretty impressive.
And in theory, ButterFS is going to be along similar boundary lines. That's what they're hoping, but it's last I read, it was still in experimental.
Well, they may have some
testing
trouble
stage.
soon because ZFS recently got ported really well over
Oh, really?
Linux. So I've been running it on my Linux box for about 2 years now.
Why butter and not better?
That's what I was thinking.
Good question. I know it's butter, but maybe it should be better.
You should go online.
And tell them how bitter I am.
How many people have come across UDF?
I've seen it once.
This is my first time.
It's used in DVD and Blu-rays.
Oh, yeah, and like if you're trying to burn large files, can't ISO 9660 not do them? So you have to burn like a CD and UDF format or
Yeah.
for long file names.
Yeah, I think ISO you can use, but it falls into a similar
It's more
trap
like
as
FAT,
FAT,
right.
where you've got short file names, you've got maximum file size. Plus, there's also the whole issue with CDs and DVDs, which is it's not a static disk. It's got to calculate how to read and write this data as it spirals through the disk at different speeds. It's a much more complicated, the hardware involved is much more complicated than just a straight drive.
Isn't it also used when you have like rewritables and you have multiple open sessions that you're not going to close, they're meant to be open?
Yeah, that's probably UDF as well, I'm sure. Any questions on any of this stuff? This is kind of slightly aside from the scope of the discussion, but it's still quite an interesting side note to have. One thing that Chase did bring up was journaling. He said that ZFS has journaling, and if you notice anything from Extent 3 onwards has journaling support. What does journaling mean? Can you come across journaling on file
I've
system?
seen it, but I can't remember. Never use it.
Oh,
If
yeah.
the power gets pulled in the middle of a write, you're still okay.
Yeah, journaling is really, really good. It has saved my backside a number of times. What it does is before it writes any data to the drive, to the file system, it creates a log file essentially saying what it's about to do or what it's just done. So I'm going to write this piece of data, I've just written this piece of data. I'm going to, I'm not sure, does it do it on reads as well, or is it just writes?
I don't know about readings.
I think it's right.
It may just be writes. And so it means that if you are writing a piece of data and your computer loses power or your drive crashes and you reboot, when it starts up, it'll check that log, that journal, and it'll say, okay, last thing I was supposed to do was to write this piece of data. And it'll then go to the file system and say, did I write that piece of data, or did I crash before it got written? And it will then, it's almost like a self-healing property. It'll keep checking things and keep a track of what happened when. And I don't know about anyone else, but Extent 4 journaling has really saved me when I've had some nasty crashes before.
Yeah, so even if the drive is mad, just FSCK on it.
Yeah.
It usually patches it all up just fine.
Especially like
Lot
if
better
you
than
could
the
imagine back in the EX2 days or something,
Or the fat days.
or the fat days. And let's say you're running like a mail server, a big one, and you got hundreds, maybe even thousands of people that are all typing their email through this, and it crashes. Like it just power gets pulled. There was no battery. There's nothing like that. Everything that was in the middle of a transaction on the drive is not only lost, but potentially their entire mail file is corrupt. Or maybe there's enough data there that, like, when the mail server comes back up, it just has no idea what to do because it sees things half written that aren't. It's not a mail file. It thinks it's there. It's not really there. It's just this corrupt piece of junk.
Yeah.
It's a bad situation.
Journaling is really good. I think NTFS initially did not use journaling, but I believe since probably Windows 7 they updated it. It now does use journaling, I believe.
Yeah, that would be.
I think they maybe even brought in journaling fairly early
Maybe.
in TFS.
I remember in the XP days, initially it didn't.
Initially it didn't. I wonder if maybe like Service Pack 3 or something.
Yeah.
I don't know.
But they didn't change the name of NTFS, so we never really know when that
Right.
shift occurred. Unlike in Apple land, if I remember rightly, HFS is non-journaling and HFS Plus is journaling, right? If I remember right. Any questions? Are we good? So
Journaling is not unlike a database engine.
yeah.
And actually, on that same note, it would be important to have a journaling file system if you're running a database server. And you have less likely to crash an entire database.
Right.
And your database will be doing journaling as well
Exactly.
within
So
itself.
there's two layers.
Yep.
So the odds of killing a database are much lower.
And on top of it, I think some of the new RAID systems use a partial journal when they do writes, especially when they're creating parity bills.
You also missed my favorite file system, which is XFS.
XFS. I only had limited amount of space. I could have put it up next
Oh,
to
there's
Rise.
clearly 3 more lines there.
Yeah.
Okay. so for the fact that I didn't add XFS or all of the other variants of file systems you can get in Linux, Joel, what's a good benefit of XFS compared to
The reason why I used it was it handled I/O better than some of the other file systems, and it deleted faster. And so in my ZoneMinder and MIFTV days, that was the file system of choice for me for the faster delete and the handling of those files better than some of the other file systems. Truthfully, I don't know. It's probably not any better today than like Butter or ZFS or maybe even EXT4. But in the EXT3 days, I could run ZoneMinder on EXT3, so I had to run it on XFS and MIFTV.
And I must
Because
admit-
MIFTV would take like, sorry,
No, go ahead.
like a 4 or 5 gigabyte recording in HD and delete it. And on some of the older file systems, it would take like minutes to delete that file. But in XFS, it just deleted the marker. So it was a more efficient file system for I/O.
And I haven't for many years since going to Extent 4, and it's fixed a lot of the problems. But when I first was doing the same as Joel and was running MythTV setup, for those of you who don't know, MythTV turns a computer into a DVR, and you can record and watch TV direct from broadcast stations. And when I was first getting into the MythTV world, I think it was the Extent 2, possibly even Extent 3 time, it was before Extent 4. And I think I had similar issues, and I think I played with XFS. And I remember using RiserFS for a while for similar reasons. Plus, it was, I think those brought in journaling before Extent 3 did, which
That sounds right.
is another reason. Now I think we've covered most of the stuff on file systems. Yeah, file systems are kind of fun. Now, for the rest of this discussion, because I want to try and keep it simple, we're actually going to be looking at back to extent 2. And if we know that all these other file systems do the same concept most of the time, but they add things like journaling or the healing process and all the rest of it. But for now, we're going to look at extent 2. And we've also got to be aware that what we're about to look at is not the same as something like file allocation table. In fact, I remember a couple of years ago, Dominic pointed out, when we were talking about file systems, that FAT uses a completely different method of storing its data than any of the extent series. So different file systems do store data in different ways. But for now, we're going to look at extent 2 and into extent 4. They're going to be very, very similar. So most of you probably know this, but how does a disk work? We split it into partitions. What are the 2 primary systems of partitioning disks now used the majority of the time? There are others, but what are the 2 big ones?
MBR and GPT.
MBR, which stands for
Master boot record.
Master Boot Record, which is the old system. And what's the new one? GPT?
Is this general?
GUID partition table.
GUID
Yeah.
partition table. Yeah.
Universal bootloader. Is that-
That's
That's correct.
yeah. That's
System will tell it how to boot. GPT or Master Boot Record is it's the underlying structure of how the disk has been partitioned. So it's not about booting, it's about how does the disk, how does the computer or the operating system find the different partitions on the disk. What's a couple of the really big differences between GPT and MBR? Where does MBR store its partition data?
In the beginning.
At the very beginning of the disk. Where does GPT store it?
Kind of all throughout it.
Wherever we
No,
want. I don't know.
it's at the beginning, but there's a duplicate at the end.
Yeah.
So if you accidentally wipe out your starting blocks, there is actually a backup at the end if you use GPT. What's a big limitation of the older MBR and why a lot of people have started to move to GPT?
You can only have 4 primary partitions.
4 primary partitions,
limit on
and
partition size.
limit on size. As Joel's doing this in the back. So yeah, partition size is a big thing. I don't remember exactly what the limit is on MBR.
4 terabytes.
It's 4 terabytes?
It is, because I ran into that.
I thought it was smaller than that. I thought it was 2.
Really? Oh, 2.
Because
Oh, yeah, it's 2. I
I
remember
hit it
now.
long before I got a 4 gigabyte.
I vividly
drive.
remember. Yeah, it was 2 terabytes.
Yeah, 2 terabytes sounds right. So if you've got and nowadays we're getting hard drives that are 3, 4, 6. You might even be getting close to an 8 terabyte drive. In fact,
Was there a workaround for MBR to go up to 4?
not that I know of. That's why GPT kind of came into its own. And there's a workaround for the initial, I think, was it Nathan suggested limit of 4 partitions.
Yes.
There was a workaround for that. Anyone remember what it was? Logical
Which
partition.
didn't really work.
And Windows has this great habit. As soon as you hit 3 partitions, it will only create a logical partition as 4. You can never have 4.
But there's still a limit to how many logical ones you can have. You can
There is a
8.
lot. Yeah.
It's not that many.
Yeah, there isn't that many. But in GPT, do we have that problem?
No.
Not really. It's pretty, if there is a limit, it's pretty damn high. Okay, so partition tabling. We've got our disk partitions. Someone want to give me a quick example of why we partition disks? I think we talked about it a month ago, but
Isolate data.
isolate data. isolate different operating systems? If I want to run Windows and I want to run Linux, can I run them on the same partition?
I'm not saying.
Probably not. You might be able to, but it's going to really. So you want to separate them. Is this making sense? I know that you're.
Yeah, I know a little bit.
You know about this. Kit, is this making sense to you? Partitions? If I gave you a test on this, you can ace it.
No.
I'm studying for a different test.
What test are you studying for?
Differential equations tomorrow.
Well, you have good luck with that because I couldn't help you out with different things. I never did.
I'm going to show up with a middle of your DQ test, and I'm going to give you another test.
Dr. Walsh would love that.
Okay, so let's look at the file system. So now we're one step removed again from the drive itself. We're now inside a partition. So extent 2, extent 3, extent 4 pretty much are the similar setup. Boot block at the beginning. What's a boot block?
This is your grub block.
That's where your initial grub block is. Is this where we get into really heavy situations when you try and install Windows after you've installed Linux?
Oh yeah.
Why?
Well, there's only been one at a time. Yeah.
Windows wipes over your boot block. It was a while ago, Dell brought out some kind of disk manager that, this was about 6 years ago. It was a random third-party tool that Dell brought out for their computers that ran only in Windows. And when it ran randomly, it would just overwrite the boot block. And of course, it would write it and say, oh yeah, there's a Windows partition here. But if you had a dual boot system, all of a sudden, you'd boot into Windows, you'd do some stuff, you'd try and reboot, and you lost your Linux thing. And you hadn't done any changes. And eventually, I figured out it was this Dell thing. Superblock. What's Superblock?
Contains the partition information.
Partition data is
It's above it.
as above. This is in the file system. What's a superblock? So want to look it up?
Is a record of the characteristics of a file system, including its size, the block size, the empty and the filled blocks and their respective counts, the size and location of the inode tables, and disk block map and usage information, and the size of the block groups.
Sounds like good, bad, and ugly stuff.
So this is the really nitty. This is all the real nitty gritty of how all of this is set up. So I had to play around with superblocks once when I had a really nasty RAID crash in MDADM, because software RAID MDADM stores its striping data and how the data has been striped in the partition superblock. So superblocks they're not nice things to play with, but it's good to know about them.
In your case, when the superblock was, when you had to go in there, like what can you do?
I ended up, what I had, this was a number of years ago, I had a disk, in fact 2 disks, because the RAID 5, I had a disk had failed and another disk had gone out of sync, and I hadn't noticed. And it's a bit like the one that I had a year or so ago, and I'm sure a lot of you remember me crying over it, and I eventually got it back. But that was hardware-based RAID, and it was RAID 6, and I had 2 drives that went bad and 1 that went out of sync. And luckily, the LSI Mega RAID system was able to figure it out. But with the older RAID 5 that I had in software using MDADM, the superblock had been updated on 3 out of the 5 drives. 1 drive had failed, and the 4th drive, the superblock data hadn't been updated. It was like a timestamp, and to tell MDADM, okay, all of these drives are in sync. And when that drive was no longer in sync, it felt it was a bad drive and said there wasn't good data on it. I can't use it. But since, all right, there might be some gammy data, but I had no backup at the time, and all of my data was lost because I couldn't start the RAID at all, what I ended up doing in MDADM, this is why I really like software RAID is because there's a lot of really good how-tos, and MDADM can do a lot of good things to help you restore when you've got a really nasty crash. And what it allows you to do is to zero out the superblock, and then you can tell it to force write a new superblock with the current timestamp and the RAID information on it, and then restart the RAID array. And though the data blocks might have corruption, I knew that I hadn't changed any data on it since that last timestamp, and so I was able to tell it, wipe it out and reset it. Is that
Nice.
That's
makes
cool.
sense?
Yes.
Wow.
And that's why I quite like MDADM, because it allows you to do things like that, which hardware-based RAID arrays really don't have the tools to do. You're pretty much almost up shit.
Well,
at that point.
The hope of a hardware RAID, though, is that can never happen.
In theory, but like I said, I had an LSI RAID 6 that took when 2 drives failed randomly, it took a third one out of sync in a similar fashion. I suspect it probably did. I was able to force it. I probably did something very similar where it wiped out its data and reset it, but it wasn't. I wasn't telling it to do it. I was just kind of pushing it in and out until it suddenly went, oh yeah, I'm happy now. I can start the RAID array. And then I had to use lots of journaling fixes to get the file system to talk on top of it. Okay, so superblock, boot block, superblock, inode table. Now we're getting into the crux here. What is the inode table and what does it hold?
The information of where all the files are, and the information about them.
The information of all the files, the information about how they're stored, and if we look at data blocks, the inode table has what? It has links to all the data blocks,
So it
which
has the
contains
locations.
So it has the locations of the data blocks that are in that file. What other thing does the inode table hold, which is really important to us if you're talking about extent 2 onwards? Permissions. Inode table holds your permissions. And this becomes really, really important further down the line when we start talking about how we look at permissions. Because permissions are stored here, they're not stored in the data blocks. And I'm sure probably a lot of you who sat through this once before remember that.
So when deleting a file, then it just goes to the inode and just deletes the link location.
You're jumping ahead a bit, but yeah.
That's how they do. That's why you still do data recovery sometimes.
Still do data.
Yeah, your data's still there if you didn't override it.
So, inode structures. So this is now an entry in the inode table. So here's where we're talking about the data blocks. And the nice thing, this is extent 2, but extent 4, etc. are going to be similar. They're probably just going to be bigger. But the lovely thing about the extent series is how versatile they are, because they have 12 direct data blocks. They have, in the inode entry in the table, it has links to up to 12 direct data blocks that would hold data. Anyone done data structures, taken the class in data structures? You know about linked lists? Do you want to explain to everyone what the basics of a linked list is?
Basically, a linked list, you have elements, and they all point to each other with pointers. So if you were at the beginning of a linked list, and you want to access the next element,
You might use that.
you just call the pointer of that data element.
So before we talk about
the
linked
next
lists,
one, so.
let's talk about an array.
Thanks, Chase. Take it away, Chase.
If you have an array, you're storing things in order, right? You know, let's just put random things in here. Actually, let's put it in order. Sorry. Let's say we're counting. And then let's say that I'm going to write code to insert, let's say I want to insert 7.5 into this, right? if this is an array, then my code has to iterate through every one of these until it figures out where the 7.5 needs to go. And then it has to move these over and create a new block for 7.5.
That could be.
So that's a lot, that's pretty intense, really. If I do a linked list, then I can put kind of these random things in memory wherever I want. I gotta keep track of them though. So, let's make some more. The idea is that, let's make these 5 and 6 and 7, 7.5, 8, 9. Let's pretend he's not here yet. But if we have two parts here, this is like a structure or a class. And we have 5, and then we have this, and this is a pointer. So let's point that to here. And then 6 is going to point to the next one. And for now, we're going to have,
Oh,
sorry.
wow.
Be careful.
Yeah.
There you go. There you go.
Let's point that up there. Let's point this over here. And then this is the end. We're going to call it null. And actually, in the details, we have to have a tail and a head to keep track of what's going on. All right, so now if I want to insert 7.5, then all I have to do is traverse these pointers, and then instead of moving my entire list, all I have to do is update a pointer.
Oh,
Did I do it wrong?
Flip.
Oh, sorry. Other way.
there you go. Hey.
All I have to do is update my pointers. So now, instead of dealing with this array and copying arrays and making things bigger, you know, because an array is a set size, you know, so if that's an array of size 6 or 5, then I have to make one bigger and copy everything over, and I have to do it through these loops. But through here, I traverse it once, I insert what I need to do by just moving some pointers around. It's a lot faster, it's a lot more efficient.
Well, for insertion.
For insertion, would it ever be slower?
Well, I mean, no, for insertion, it's faster than for an array is,
Right.
but you shouldn't say that it's more efficient or faster in general, because
Well, yeah.
searching, for example,
Right,
if
an array
you had
would
an
be-
ordered array,
Right. That's true.
But the great thing about linked lists is that it doesn't have to just be a random line.
right?
What would be another linked list that would be ordered and probably faster than doing a linear search through an array?
Stack or queue.
A queue, or how? That's still a line. How about a tree?
B tree.
That's where you're
Binary
trying
tree.
to find the best of both worlds.
Yeah. So,
But
taking
you still have, in terms of speed, like if you're doing sequential data access, array is going to be faster than any linked structure because the memory is adjacent.
within a certain range.
Yeah.
I guess
And
your
then-
head.
and then, but once you get certain size,
I
a binary tree starts getting faster.
think you still have to compute the address of the next, where the next data is. So arrays may
For
be
an
a
array,
little
it's
faster, but
plus
not
one.
much. But because with linked list, you have the link. With the array element, you have to
But
take
that's
the
a-
opposite of the array.
I
That's
want to
memory
actually
access.
continue on that example.
Yeah,
So
but
you have to
still
access memory to get the next.
No,
one.
you
have-
can-
have
you can
to
keep going.
build
I want you
memory
to keep
first
going.
And then access it. So with your linked list, you just take the memory up, and then you access from the link and access memory to the next node.
Which is a slower operation than plus one.
Well, +1, but you still have to build the address of the memory location to go to it.
No, you
And
already
what,
have it. You
and
already
what
have it.
happens
You have
if,
the array.
if it's
Array.
not just
The array
plus-
is the address.
Yeah, but you still have to add one cell to it to get the
While we're at
address.
it, another big advantage of this
That's hidden from you in the
is
book.
an array, you're somewhat limited. These can be like, these can contain a lot more things than just what an array can.
Well, an array can be
Well,
an
you have
array of
structures.
pointers.
Right.
Well, an array of
yeah, I
structs.
guess you're right.
So what happens if Chase deletes his head node?
Start.
The kite flies away.
You lose the access to the array.
But this is all still in memory.
That's also the memory. But you've now lost your ability to connect to it. So if you're deleting, you need to delete one by one by one by one. But a system can say when that head node gets deleted, keep track of all these, and then slowly delete them one by one, or allow them to be things. Now, what was it both Dominic and Keenan said? An array of pointers. So you have an array, but each of those points to a node. You said that was really fast because you could access through the array.
Well, I was just saying,
then you
if
could,
you wanted to store more than just a single data element in an array.
So let's go back to this. Nathan, you want to come back? So let's come back to this, and let's have a look. Let's forget about this stuff right now. What's 0 to 11? Is that not an array that points to data blocks, or an array of head nodes, essentially? That's exactly what we've just talked about. So this is how the file system structure works in extent 2 through 4, is it's an array of pointers to different data blocks. But how much data can I store in each of these data blocks? What did I say originally when we were looking at that example half an hour ago? That I said the blocks of data were how big?
Kilobyte.
A kilobyte. So how much data can I store? So we can store really easily, and we can access really quickly 11 kilobytes of data. But how many files are there that are bigger than 11 kilobytes? What we were talking about earlier, video files that are larger than 4 terabytes. So how does it store them? Well, it can use these indirect pointer blocks that each have additional pointers to data blocks. So a little bit like our linked list, we have links to links to links. And so we can store more and more. And then we have another set which is 2 levels of that. And a third set which is 3 levels. So all of that can store, and we were talking about 1 kilobyte, the maximum file size allocation for a block is actually 4 kilobytes in extent 2, and I think it's actually larger in extent 4 now. But for a 4 kilobyte data block size, we can get a file that's 4 terabytes in size. Or we can get a really small file. So it's very versatile.
Oh, okay, because you're saying that
Making sense?
that's the file, that's actually how it's storing the information.
That's the data in the file, the DB blocks.
DB blocks.
And then the indirect pointer blocks are pointers to more data blocks. So it can store really small files in those initial ones, and then really big files can branch over to all of these indirect pointers. And it's just a very, very, very big linked list. And then when you delete a file, the file system actually takes the head node of each of these pointers and shifts it into a thing what it calls free space. And it still has all of those links to all of those different data blocks, but it says these are now freely allocated. Any questions? What might this be really useful for?
Storing files.
Storing files, allowing for non-continuous block storage and random access to block, according to my original one.
There's no permissions.
Where are file permissions and ownership information stored? In the inode entry.
In the entry, okay, so that walk a set
Well,
of
all of that is data. All of this are pointers to data. But where the fuck? Yeah. Up in that initial section of the entry. So it's not stored, so the file permissions are not stored in the data blocks. It's still stored in the inode entry. We good? All right, so now that we know that, let's use stat. What does stat do? What does the command stat do? I know that some of you have done this before with me in March. Anyone remember what stat gives us?
If nobody knows what it is, if you take a class, you try to turn the file, you could with a handling command. You get a feedback, could not stat that file number.
Could not stat.
So that might draw a connection with it.
Is for file or system status or file system status?
Yeah. So it is reading the data and showing us the data from the file, from the data blocks,
File system.
or from the inode table. From the inode table. So if it's showing data about that file from the inode table, does any user have direct access to the inode table? Yeah. So any user can stat any file or directory because you're not talking about data blocks, you're talking about looking at the inode table. So in terms of security, this is something to be aware of, is anything that's statted is not about permissions because it's all referenced to the inode table. So what have we got here? We've got, if we look at a directory, there's our access that the inode's specifying. We've got 3 dates and times. What do these 3 dates and times mean?
Access modified and changed.
So what do they mean?
When was last access? When was last modified? Change is interesting.
Yeah.
Change is interesting. I don't know what that is.
It's the exact same time as modified to a fraction of a
It's
second.
the exact same thing as modified.
Yeah.
Well,
I mean the words.
if you want to do some research on that, there are differences. You don't have to do it now, but change is modified. There are some slight differences. 2 weeks ago, I know most of you weren't actually here 2 weeks ago, but we talked about UID and GID. What is a UID and a GID? Is that my username? No. It's a number. And that number is unique to every user in the system. The name may be unique, but the name is secondary to the ID itself. We've got our file size. What about this?
No, blocks.
Blocks. What does that mean?
How many blocks is taking up on the actual hard drive?
How many data blocks it's taking up? And do you remember the number 8 when it said total? In the LS, you were wondering what that total was? That total is the number of blocks that it's using, the number of data blocks. Its type is a directory. If we look at the file, we've got slightly differences. Regular empty file, blocks is 0. But the big thing that we should probably look at is inode. What's this?
It's the database ID.
That's the inode table's database ID. And it's unique to every file. And for those of you who did this in March, what's a directory?
It's just inode.
It's just another file, just a slightly different type. So stat is really useful to see it. And we can now look at inode tables. And Keenan, you might remember this from Keras, because this is very similar to Keras. So what have we got? We've got a directory is just a file, and it has a set of block pointers. But instead of having ordinary data, like file data in the pointers, it's got a table. And what's that table specifying?
Or inodes.
The name, the file name, or the other directory name, and the inode that relates to it. And we can actually follow this all the way through. So this is the table for this inode, which is a test directory that we were looking at just a minute ago. And then directory 1 inside that points to this inode, which in the inode table happens to be another directory, which has its own table, and inside that is a file name with its inode pointing at this inode number in the table.
So,
You kind of see that how similar files and directories are treated with the file system.
so in a sense, the inode directory number is its actual file name. If you, for the system.
For the system, yeah. And
I mean, it's the super file name. It's like
it's like in a database. It's
the key.
the primary key. So the file names, though we have a specification that no file name should be the same inside a directory, we can have the same file name in theory because it will have different inode numbers. It's just we specify must not have the same file name in that directory because it gets very confusing for humans. So I think we kind of went through those two, but how about this guy? We talked about it. What is it?
Parent.
It's a parent. So if it's a parent, but all this is just a list of names and their respective inodes, what's that pointing to? What's that listing as?
The last, well, the one that points to
The inode number of the parent directory. Yeah? How about this one? What's that pointing to?
Itself.
The inode number of itself. But it's not, we talk about current directory or itself, but actually all it is a table entry that points to a certain inode number.
just happens to be
It just happens to be the same inode number as the one you're in. So when we start really getting into it, we can really get into stuff. So let's drop back.
What's the triple dot?
The triple dot?
Oh, that's just
Oh, sorry. Never mind.
ellipses.
Oh yeah, that's just there's extra information here which I didn't include.
Okay.
Things like the stuff we were talking about. So what were we talking about earlier?
So if we didn't record the dot and the single dot, basically we would have no concept of directory structure. Correct.
I'm
So
sorry, say that again?
We would have no concept of directory structure. We have no idea where these things should be shown to the human. right?
Absolutely.
It's total chaos
Yeah.
to us.
To us.
If it was anything but that. So if we look back at the stack, all that other information you're talking about is all these other things. So the access modified chain, the access permissions, all of that stuff is the stuff that I didn't include in that.
Oh, I got it.
that dot dot dot. Now, is this links? Yes. Now let's look at links in here. You know how we had the dot and the why would we have two links for this directory?
Because it has the dot, which is itself pointing back to it, but then it also has the file in it that has a dot.
Well, that's the file. No, the file is this. Maybe we should go on to some different slide. It'll probably make more sense. We've done all of that. Next. Okay. So it has two. We can see it here. It has two links. These are all the links. One is the dot. The other one is not from the file. The file itself doesn't have any other than one link, which is this listing. So where's the second link? Here? In the parent directory?
Pointing back down to it.
Pointing down to it. So there's your two links. You've got one which is in the parent directory with its listing for directory 2, sorry, for directory 1, and the second one is its own link. And then if we look at our earlier directory, how many links does it have? 4. Why? There's its dots, there's 1.
The DR1 has one link back to it.
DR1 has this one back to it.
And DR2 also.
DR2 has this one back to it. That's 3.
And the parent above it has one there.
And the parent above it has 4. So there's our 4 links. Are all connected. Making sense?
Yeah.
How about the file? How many links does it have?
Just itself.
Just one, not itself,
Directory
one in the directory that it's inside
Yeah.
is linking to it. But files don't have all these extra.
Because they don't go anywhere else.
They don't go anywhere else. Any questions? Anything that you want to add? All right. In that case, let's move on to why this is useful to us. I know that those of you who've done this before know what's probably coming up. Hard links versus symbolic links. And I seem to remember a certain young lady asked me what the difference was between a hard link and symbolic link. Do you remember?
I remember it was like they go to different places, or
Kind of.
something like that.
We're talking about hard links initially. When we talk about links, we're talking about hard links. And we're talking about the link being a directory listing that attaches or shows a name of a file or name of a directory to its inode number. And so we can create this is where the hard links come in. We can create multiple hard links to the same inode. And that's what these two are. That's in directory 1, that's in directory 2, but they're pointing to the same inode. So they are both hard links to the same data. What else is held in here? What else is held in the inode table for that specific file?
In the entry.
In the entry, as well as the data itself. What
File
else?
creation and
Modification dates, creation dates, ownership, and permissions. So that means that what? If I create a hard link called that in a different directory that points to the same inode number as this, it's going to have the same permissions, it's going to have the same creation date, the same modification date. It's all going to be exact duplicate, except it can be accessed in a different directory.
And the data is not duplicated either.
And the data is not duplicated. The data is also the same. Now, how about soft link?
That was a little fuzzy for me.
Soft links?
Yeah.
Okay, well then let's look at soft links. So here's a soft link. Now, does this have the same inode as these two? No. So this is slightly different. This is a file unto itself with its own inode, its own number of links, which is only 1 compared to the other inode for the hard links that has 2. And it's also, in theory, got different permissions, different times it was accessed, etc., etc. Now, in the grand scheme of things, when we look at soft links in the system, it'll often reference the file that it's actually pointing to. I'll give you information on that. But we can, when we're programming, look at either the link information from the inode versus what it's pointing to. So here's the biggest difference. If this and that have the same inode and therefore have the same block pointers in data, but the other is a symbolic link and has its own inode table, it means it also has its own data block pointers. So what's in its data block?
link to the actual directory of the file.
Well, it's not a link, but it's
A pointer to where it's supposed to.
it's not a pointer, because pointer we go back to talking about
Yeah.
linked lists. It's a reference of a path. It's a path name reference, and we can have two different variants of the path name. One can be absolute from our root directory. The other can be what?
From where it's at. The parent.
Relative. So
So a
relative to where it's at currently.
So a soft link could be potentially orphaned
Yep. Soft link can be potentially orphaned. Why?
because you could delete the hard data, and
Yeah.
the soft link is just pointing to a location.
A location that doesn't exist. A reference to something that doesn't exist.
So, but if you had a hard link, per se, you could delete it there, and the data is still over here for the other thing to use.
If I deleted this,
It's still
that
there.
is still there.
That's still there.
What happens to the link count?
Link count goes down.
Goes down by what? If I delete that, what happens to the link count? So where does it end up?
0.
0. And the file system says if link count equals 0, scrub out the inode. That file's gone. So hard links are really useful because I can create multiple copies.
Now I understand your backup.
Now you understand the backup
That's
script.
good.
Because the hard links become really, really useful if you're taking snapshots of data. Because I can delete this, but that is still there. And it's not until that gets deleted that the data gets deleted. Symbolic links are problematic that if this gets deleted, that symbolic link no longer holds the data, it's just a flailing pointer that doesn't point anywhere. It
It's
exists.
useful data.
Doesn't have any use of data. But, sorry, go ahead.
Oh, I guess then my question is, what case would you use a soft link?
What case would you use a soft link? Anyone want to give a good example?
Multiple hard drives.
Okay.
Oh, because it can't. Oh.
So let's think about what these inodes are. Where are they being stored?
In
They're being
a file system.
in the file system on a certain partition. If I've got two different partitions or two completely different drives, I'm going to have two different inode tables. And if I try and say it's the same inode number, what's going to happen? It's going to get really confused because
May not
it's going
exist.
to it's going to be pointing to a different data block in a completely different partition.
So it's a way to access.
So symbolic links, because they work at the human level of the directory structure rather than the inode table structure, they can be used to link to external drives or other partitions or what have you. So there's pros and cons to both.
See, I wish they would
Yeah.
be soft. I wish they just be symbolic. Is that
What's also really
More
important is you can
explained.
also set different permissions on your link
Yeah.
than your other file, because it gets its own permission table.
Yeah.
So your symbolic link can have whole different permissions in the original file.
In
itself.
theory,
Yeah.
but it doesn't always work like that. Usually a symbolic link will actually have permissions of 777.
Yeah.
And actually we can probably look at that. So we've,
So, yeah, I guess if they wouldn't say soft, it'd make me better.
yeah, sometimes they call it a bit like me with other versus world.
Yeah.
Some people call them hard and soft. Some people call it hard links and
Symbolic.
symbolic links. Windows, what does Windows call it? Shortcuts. It's the same concept in Windows, except they call them shortcuts.
It's junctions, is that what they call it?
Oh yeah? Is that the hard link?
The hard link is a junction.
I didn't know that Windows could do that.
Yeah.
It's incredibly difficult to make that.
Oh, it's not right.
Make a junction with.
It's a command.
There's I think at this point, it's probably easier to do a PowerShell.
There's a GUI.
No, there's
not.
not actually.
That's what I wondered.
That's what I
Like,
had
oh, we
discovered.
can build
There's
one
no
with Visual
GUI.
Basic.
Oh yeah, right. Visual Studio is the GUI.
I think that's why they're not really used, is because there's no easy way to create them.
I had to do it when I was trying to move my program files to a different area on my computer.
Is this making sense to you?
After installation.
Yes, after installation.
You got questions?
Well, you can't, I don't think. Is there any way to separate that on the fly?
But you understand the basic concepts. That we're talking about how the file system works,
I had a hard
and
time.
therefore where things like file permissions are stored versus where the data itself is stored. Did you do the exercise on permissions 2 weeks ago on permissions?
No.
You weren't in. Okay. Maybe we should revisit that sometime.
Yeah.
I know that there were some like viruses that were exploiting that whole junction thing.
Didn't make jumps to, it
They
wouldn't show up.
couldn't find them unless you were using some different forensic technique tool.
And that's not.
Because Windows Explorer doesn't show you.
Yeah, and that's a nice thing about Linux is that we can see when things like hard links are created. We can see it in.
Different colors and stuff.
We can see it, and yeah, if you do, and here's the actual commands that will create the hard link for this and that. So there's this, there's that. Here's a command for a symbolic link, which is the option S. And if you notice, I tell it the path, and notice how this is what kind of path? It's a relative path. I could have used an absolute path. So the path to what they call the target, and then that's the name of the symbolic link. And if you notice, it's slightly different in context. Why? Why is there a difference between how I've specified the hard link, where it's directory1/this, versus the symbolic link, where I've got the double dot /directory1/this? Why is there a difference? If I look at the link that I'm creating, I'm saying I'm in test directory and go to directory 1 and grab this inode and then make it a new thing in directory 2 called that. Whereas the symbolic version, this target is reference to where the symbolic link will be. So if you notice, the symbolic link is in directory 2, the other, which is here. And so I'm saying go back one step to the test directory, go down into directory 1, and then pick this. So when you do a symbolic link, you've got to be aware that your path you're specifying is from where you're storing the symbolic link, not from where you currently are residing.
So while it's relative, if you move DAR1 and 2 to another directory on the system, it should still work just fine.
It should still work because it's relative. If it was absolute, it probably wouldn't. It would be a hanging link. And if you notice with the long listing, the other is expanded out, and we can see
Basically the data
it's data which is pointing to that relative path name. Also, take a look at the type. If you notice on both on both this and that, the type is what kind of file type? It's just a regular file. The dash means regular file, yeah?
Right.
Whereas, what's the file type for the other? L. And L represents a new file type which says this is a symbolic link.
Oh,
So if you see L, it means that's a link to something. Whereas we don't know that these are the same unless we start looking at file numbers, at inode numbers. We have no idea that this and that are actually the same file. Whereas,
that's the inode number right there in the front.
yeah,
How do you get that to display on LS?
ls-i.
Dash I. So
I
if I
shows
just put the I in, and I can get my.
You can show
inode.
your inode numbers. You can also notice links. The link count for file 1 is 1 because there's only one entry for it.
And that
Whereas,
comes up.
sorry?
That comes up with the I as well.
Well, that will come up with a long listing. link counts come up with long list.
Okay.
Whereas this and that both have a count of 2, the other only has a count of 1 because it's only got one connection to it. Could I create a hard link to a symbolic link?
Yeah.
Theoretically, I don't know whether in practice you can, but theoretically you could create a hard link to a symbolic link. It may actually dereference and go and create a hard link of the file it's pointing to. I don't know, but that'd be an interesting little exercise to try. Can you create? Can you make a symbolic link have more than one link?
But what would be the real purpose?
Oh, that's also a good question.
It's specific.
To break stuff.
Because you wouldn't be saving much data, just a small reference.
Yeah.
So you're doing-
Notice the other thing that we discussed earlier. The time that this was last modified for this and that are the same. But if you notice, I created the link for this and that almost exactly the same time as the other. But notice the difference in timestamp 2 days later for the symbolic link.
So
Because it's a whole new line.
to make a hard link of that soft link, that would probably happen in your script.
No,
Because if you have any soft links in your directory, then your script would
yeah.
then
It probably
attempt
would.
to hard link
I
it.
wonder if it would hard link or if it would link directly to the old. Yeah, you're probably right. It probably would. So maybe you can create link
Unless you're getting
multiple
errors,
links
I would
to.
say.
Yeah, you're probably right. It's good. Good answer. Any questions? Why can't we make hard links to directories? Because if you try and create a hard link to a directory,
Wow.
it'll error out.
Because it's trying to make the directory again.
It's not trying to make the directory again, it's purposely put into the Linux operating system. It says do not make any more links than the links that the system will create. Well, it can be more if you notice
Yeah.
the parent directory because it's got lots and lots of other directories inside it. But only make the ones that the system allows, don't make any that the user specifies. Why not? Loops. I could create in fact, let's do it on here. I could create a loop that goes directory 1, back to directory 1, back to directory 1, and it can never resolve it. It can never end anything. It just becomes an infinite linkage.
Doesn't the kernel put a limit on that?
So yes, it's the operating system. The kernel actually says we do not create hard links. Can I create a soft link to a directory? Yeah. Yeah, and that's actually another really useful reason why we have soft links and when to use soft links is if instead of doing it with a file or doing it with a directory.
So if you created a hard link like that, you could make a loop that you couldn't get out. You'd have to crash the system, right?
You'd always get out.
Well,
Yeah.
you wouldn't.
It doesn't allow you to do it because of that.
Because you could make yourself trapped.
Because you can make yourself trapped on hard links. Now, soft links you can, but the system has a specification that says only have so many soft links. Because you can have a soft link to another soft link, but you can only have, I think, in extent 2 it was 5 soft link.
Well, that's not even a kernel config. That's just a thing.
I think I know it may be a Linux system. I'm not sure. It's been a while since I've read about soft link limitations. I think nowadays it's 16. You can have you can hop. So you can make I can make a soft link to this, and then I can make another soft link to that, and another soft link, and another soft link. But I can only do it 16 times before it says no, you can't do it anymore, because it doesn't want to keep chasing the rabbit down the rabbit hole as we would do if we were able to make hard links to directories or soft links to directories. It's going to eventually resolve itself. Making sense? Any question?
Where can we go to edit that so we can make hard links?
Probably have to compile your own
Yeah, if you
kernel.
compile a Linux kernel.
Well, I'm just wondering if there's a config option in the kernel. That's I'm sure there is.
There may
Yeah,
be somewhere.
like somewhere.
There may be somewhere.
Yeah, probably.
So, I know that those of you who did this with me before helped me to answer this, but why don't we visit this in the last 10 minutes that we've got? This was a question that came up in an exam for the information assurance and security class. The people who were here 2 weeks ago are currently taking it. I hope that they would be here today, and of course none showed up. And I brought this to Keenan when it was on my exam, and we tested it because I was certain that this was really, really tricksy. But a regular text file is created in a Linux system by the root user. User Joel is granted ownership of the file with the following permissions: read write to whom?
User.
To him. Read write to
Group.
the ownership of the group, and read only to
Everyone else.
everyone else. Does Joel have the ability to change text in the file? With those permissions, having been given granted ownership, does he?
Yeah.
Yeah. He has the ability to change the text in the file. Okay. Does Joel have the ability to delete the text file? Not the text in the file, but the file itself.
Well, that depends on his permissions on the directory in which the file is contained.
Yeah. Have we been given that information?
No.
We cannot answer this question. And actually, only this was asked in the exam for Dr. John D. Waller's class last year. And because he hadn't thought it through, he was thinking, well, it's an easy question. And he was asking a bunch of people who hardly knew anything about Linux this question. And I sat there for 20 minutes in the exam going,
This is a trick.
There's no way you can answer that. Because yes, you're absolutely right. You cannot answer it because we don't know what the permissions are on the directory. And now that you've sat in here for the last hour and a half, you should know exactly why that is. Because the file permissions are held in the inode table.
You can't look at inode without the permissions of the other one.
Exactly. So yeah, and last time we did do a live demonstration of this, and if you really want, I can do it, but I'm inclined to say you all can probably get on and do that if you really want to do it. But I think you understand.
This is awesome.
Yeah?
You get to post this on the.
I can probably post it somewhere. I don't know where. We don't really use.
It'll be on the YouTube channel.
Yeah, we'll have to piece it together now, the video, right?
And this is me doing a shameless plug. I'm not getting money from him, but I love this textbook. I know I plugged this in March, and Keenan can attest to this. Keenan found this textbook for his class I took 2 years ago.
I found that textbook. I don't know how I found it. It looked interesting, and that's when I offered to teach the course. A lot of the students were not, mainly registered, were not ready for the course. I was shocked.
This was advanced Unix programming, and it really was advanced Unix programming. And this book really goes in depth. And this is where I really started to understand how things like inodes and file permissions and things work. Was from this book.
That's a good read. Every time I reread a chapter,